We see the three modes of reasoning as applicable in the context of AI systems, namely inductive, deductive, and abductive reasoning. And in context of abductive reasoning, let's explore the phenomena in a bit more detail. So, we already understood in a context of abductive reasoning, there is usually reference of a problem statement of the form cause effect. It could in fact be a multiple cause causing the same effect. So when you say there are multiple causes to the same effect, the kind of use cases which are applicable in terms of abductive reasoning are those which typically involve some kind of a diagnosis. When you say diagnosis, we usually observe a visible effect, also known as symptom, right? Symptom is nothing but a visible effect. And in presence of a visible symptom, our problem in AI is to infer what is the most likely cause, or is it a combination of multiple causes? That's a very common requirement in AI systems. Extending that, we could also ask the question, what is the relative weight of a particular cause for a particular symptom? So in that sense, we can also make it a game of something like a probability. For example, what is the probability of a certain symptom having been caused by a specific cause? So if you see, abductive reasoning is a very powerful technique wherever we have notion of diagnosis. So what kind of use cases will be looking at this kind of a system? So the most common use case which is very prevalent in our day-to-day life is healthcare. So in healthcare, we have several scenarios where we observe symptoms and the doctor tries to diagnose, right? He tries to diagnose the root cause of what is a potential cause for your symptom. For example, it's possible that you will be running a very high temperature. That's a visible symptom. But what could be the cause? It could be that it is plain common cold or fever. Or it could be in a special case, it could be malaria. Or even it could be a very special case of typhoid. But then your system can also use the past history of occurrences of combinations of a cause like typhoid and high temperature, or cause of common cold and temperature, and give a relative weight in terms of what is the probability of a specific cause like typhoid having caused high temperature, or probability of a common cold causing high temperature. So the idea is, in healthcare scenarios, abductive reasoning plays a very important role, especially because of its nature of diagnosis being the primary filters. In addition to healthcare, there are other scenarios where we need to carry out intelligent diagnosis via abductive reasoning. For example, wherever there is a question of any kind of repair, where you're seeing some kind of a symptom which is related to failure, or some machinery not working, or some IT system not working, you have to find out the potential cause or root cause, or it could be a cascaded cause which is causing another cause which is causing another repair. So in the context of repair-based use cases of abductive reasoning, we usually try to identify the symptom which is usually some kind of a fault or visible fault which you observe, and then you try to do an identification of what's the possible cause. There could be multiple causes. Try to identify what the most likely cause, and then come up with something known as root cause analysis of the particular symptom, and then this gives the formation of the basis of how you're going to rectify and remove the symptom. So this kind of a scenario occurs in several verticals. For example, it could be in form of industrial machinery, or it could be in form of IT systems, like say, somebody reporting error message on the screen saying some system is not working. So you'll go and do a root cause analysis. So in case of abductive reasoning as applied to such kind of a scenario of AI-based system, we try to create a knowledge base which is something like this, where we create a network of cause-effect relationships where we try to trace the relative weight of each cause on each particular effect. For example, if you say cause 1 has 30% times causing this repair, or cause 2 has caused 70% this repair, so we can have a network like this. This cause again can be caused by another cause. This could probably be something like 0.4, 0.6. So such kind of diagnostic networks are an important AI kind of an applications where abductive reasoning is used, especially in context of either healthcare or industrial repair or IT systems maintenance, etc. And there are several machine learning and other variant algorithms which are able to take this kind of an approach. Like for example, one of the very popular technique is known as Bayesian reasoning, where Bayesian reasoning tries to create such cause-effect relationship in form of something like a Bayesian network. And a Bayesian network can be your AI knowledge representation, which can be used for applying in any context of a potential healthcare diagnostic or a potential industrial repair scenario or an IT system repair scenario. So we see that abductive reasoning is a very powerful reasoning phenomena in the context of AI systems.